Hello, this is the EE301 final exam review packet, problems 1, 2, and 3. So these problems concern DC circuit analysis, and we'll begin with problem 1. Problem 1 says to determine the total resistance as seen by the source of the circuit below, and then find the source current and I1 and 2. So the first thing we'll do is you're going to want to find the source and then go to the other side of the circuit. That's typically where you'll want to start finding total resistance. So we want to identify the nodes. So we'll draw them in red. We'll notice that this is a node right here, and then this is a node right here. So if we take a look at the circuit, we'll notice that 15 and 5 are in series with each other. So we can combine them just by adding them together, and that makes a 20 ohm resistor. And then if we take the left and right side of this parallel network here, we'll combine them in parallel, and we'll call that REQ. The reason we know that they're in parallel is because they share the same top and bottom node. So that's just 1 over 12 plus 1 over 20. And then that's all to the -1 power, or you just do 1 over the whole thing in your calculator. So that's going to give us 7.5 ohms. And then lastly, we'll find RT by adding the 10 in series with the parallel network here. So that's 10 plus 7.5. That gives us 17.5 ohms. And that is the total resistance of the circuit. Next step is to find the source current. Using Ohm's law, we know that source current will equal the source voltage divided by the total resistance. That is 30 over 7.5 ohms, and that gives us, my apologies, 17.5 ohms, and that gives us 1.714 amps. Next, we'll have to use the current divider rule in order to solve for I1 and I2. So before, we found REQ, which was the resistance of the parallel network. So if we use the current divider rule, which was IX equals IEQ times REQ over RX, X being the branch of interest, REQ being the resistance of the parallel network, and then IEQ being the current that goes into the parallel network. We'll use these to solve for both numbers. So I1 will be equal to IEQ, which is the source current. So that is 1.714. And then that is times, my apologies, the resistance of the entire parallel network, which is REQ up here. So that's 7.5. And then the resistance of the branch of interest, I1 being the branch with the 12 ohm resistor. So putting that together, that gives us 1.071 amps. Solving for current 2, we have the same source current, the same equivalent resistance of the parallel network, and then on the bottom, we have 20, which is a combination of the 15 and the 5 ohm resistors that are in series that make up that branch. And that gives us 0.643 amps. And those are our answers. So, part 2. Part 2 asks us to find the power delivered by the source and then find the power of every resistor. So, since we have all the currents, our friend will be the equation power equals I squared times R. You can use the other power equations, V squared over R or V times I. However, because you have the currents, this would be the most direct one to use for everything, except for the source, in which we'll use the current times voltage equation. So first step, we'll find source power being the power of the voltage of the battery. times the source current, which is 1.714. Remember, this was voltage of the battery or voltage of the source times current of the source. And that is roughly 51.42 watts. Now, the next step is to solve for the power of the 10 ohm resistor. And for all of these, we will just plug in the resistance and then the corresponding current to match that resistance. So in the case of the 10 ohm resistor, we have a 10 ohm resistor, and then if we look in the circuit, the source current is going through it. So that will be 1.714. And current in this case is squared. Remember that. So that will give us 29.38 watts for the 10 ohm resistor. Next, we'll do the 12 ohm. So we have 12, and then that's times. Now, if we look at the 12 ohm resistor, I1, current 1 is going through it. So we'll plug in our value for current 1, which was 1.071. And that's squared, and that will give us 13.76 watts. Next, we'll solve for power of the 15 ohm resistor. And that will be the same process where we will plug in the current, which is, or my apologies, the resistance, which is 15, and then the current, I2 going through it, which is 0.693 squared. And that gives us 6.20 watts. Lastly, power of the 5 ohm, that is 5 ohms with the same current that was flowing through the 15. So that will finally give us 2.07 watts. Now, if you notice, when you answer the final part, does the power being delivered equal the total power being absorbed? So what you'll do to test that is you'll say, does source power equal the sum of all resistor powers? And in this case, PS equals 51.42. And does that equal the power of resistor 10, which is 29.38, 13.76, 6.20, and 2.07. And those numbers do equal. So give that a big check. Lastly, we're being asked to use nodal analysis to find the voltage at V, which I've circled right here. So on the left side, I will use nodal analysis to solve for that. We will identify our nodes of interest, and then we will plug our numbers in. So our nodes of interest will be this one, V, and then we will also be interested in this one right here, which is at 30 volts. We know that because the battery is connected to ground on the bottom, and then above it is 30. So the difference between those points is just 30. So we'll start with drawing our equation. We will use IS. So we'll do currents going in minus the currents going out. So IS minus I1 minus I2. And we will not use the numerical values because we're trying to solve purely with nodal analysis. So IS becomes 30 minus V over 10. I1 becomes V divided by 12. I2 becomes V divided by 20. Now, and then that equals 0. The sum should always equal 0. Now that 20, if anyone's confused, came from the 15 and the 5 being added together. All right, now that we have the equation built, all we have to do is solve for v. So you can either use the number solver on your calculator, or I'm going to walk through just the algebra steps so that everyone is comfortable with it. The first thing you're going to want to do is distribute this 10 to the top and bottom, or sorry, to both numbers in the top. So you'll end up with 3 minus v over 10 minus v over 12 minus v over 20. We will add these v values to the other side. So we'll get 3 equals v over 10 plus v over 12 plus v over 20. Now we will factor out v. So we'll get 3 equals v over 1 over 10 plus 1 over 12 plus 1 over 20. And finally, we will divide both sides by this quantity here. So we'll get v equals 3 over the quantity 1 over 10 plus 1 over 12 plus 1 over 20. And that roughly gives us 12.88 volts. Now, the next part of the question asks us to solve using Ohm's law. So Ohm's law on the 12 ohm resistor says that the voltage of the 12 ohm resistor is equal to 12 ohms times the current going through that resistor, which was I1. So that current was 1.071. And that gives us 12.85-ish, which are essentially the same. Any differences are due to simple rounding. So yes, that proves that we can solve the problem in multiple ways. Most likely you would want to just use Ohm's law for this case because it was a bit short. It was quite a bit shorter, but you can also solve it with nodal analysis. And that is problem 1 and 3 of the final exam review packet.